friends, in the first part of Vedic math, we saw techniques like multiplication of numbers with a series of 1, multiplication of numbers with a series of 9, but these techniques had their restrictions. In the second segment, we'll see generic examples which can be used for numbers of any type. Sky is the limit. I'll teach you numbers of multiplication higher orders, addition, subtraction, then we'll go to squaring, square root, cube root, algebra and geometry. My aim is to ensure that you can use these techniques in different parts of your paper. So gradually we'll move ahead sequence by sequence and study these techniques of math. So the first technique that I'm going to teach you is multiplication using designs. We also call it the crisscross technique of multiplication. Using this, you can get the answer of any multiplication problem in just one line. So first, let us see how to multiply two-digit numbers by two-digit numbers. When I multiply two-digit numbers by two-digit numbers, I use 3 steps. Here are the steps. We will call them A, B and C. To explain them, I will make some designs as given here. There are 2 dots above, 2 dots below. So in this case, we use 3 steps which we call them I, X, I. Let us take 1 or 2 small examples. Suppose I have to multiply, say, 32 by 21. Then this dot represents 3, this dot represents 2, this dot represents this 2 and this dot represents 1. First step says you multiply these two numbers right and right. We know 2 times 1 is 2. Then we go like this and like this. We will add both the answers. 3 times 1 is 3. Keep it in your mind. 2 times 2 is 4. 3 plus 4 gives 7. Last step says multiply these two numbers. So 3 times 2 is 6. My answer in this case is 672. This is the beauty of Vedic maths. You can get the answer in only one line. Let me quickly revise this example for you. First step says multiply these two numbers right and right. So 2 times 1 is 2. Second step says cross multiply this and this. We will add both the answers. 3 times 1 is 3. I put 3 in my mind. 2 times 2 is 4. 3 plus 4 is 7. Last step says multiply these two numbers. 3 times 2 is 6. My final answer is 672. So let us take one more simple example. Suppose I have to multiply, say, 34 by 11. First step says multiply these two numbers. 4 ones are 4. Second step says take like this and like this. We will add both the answers. 3 ones are 3. Keep 3 in your mind. 4 ones are 4. So 3 and 4 gives 7. Last step says multiply these two numbers. 3 times 1 is 3. My final answer is 374. Like that. Suppose I have to multiply, say, 44 by 22. First step says multiply these two numbers. So 4 times 2 is 8. Second step says multiply cross and cross. We will add both the answers. 4 times 2 is 8. Keep 8 in your mind. Again 4 times 2 is 8. 8 plus 8 gives me 16. I write 6 and carry over 1. And my last step says multiply these two numbers. So 4 times 2 is 8 and 1 carried over gives me 9. As you can see, we got the final answer in just one line. Our final answer is 968. Suppose I have to multiply, say, 51 times 71. First step says multiply these two numbers. So 1 times 1 is 1. Second step says we'll cross multiply and add. So multiply these two numbers. 5 times 1 is 5. I keep 5 in my mind. Multiply these two numbers. 7 times 1 is 7. 5 plus 7 is 12. I write 2, carry over 1. Final step says multiply these two numbers. 5 times 7 is 35 and 1 added gives me 36. So you see my final answer, I just got it in one line. It is 3621. Friends, we saw how we can quickly multiply two-digit numbers. But what about higher order numbers? Let us have a look at the design of all of them. Suppose I have to multiply a 3-digit number by another 3-digit number. We will be using 5 steps in this case, which I will represent by the letters A, B, C, D, E. Here we will be multiplying 3-digit numbers by 3-digit numbers. So I will put 3 dots above and 3 dots below. So in all the 5 steps, I will put 3 dots above and 3 dots below. And then we will see how we can join these dots, get some design which will help us in finding the answer. So here the design will be like this. We begin from the right, we take 1, move towards the left, we take 2, move further towards the left, we take all 3, move to the left, we get 2, move to the left, we get 1. So there are 5 steps. We multiply these two numbers. In the second step, we multiply like this and like this. We will add both the answers. In the third step, we multiply these two numbers, these two numbers, these two numbers. We will add all the 3 answers. In the fourth step, we multiply like this and like this. And in the last step, we multiply these two numbers. Let us have a look at an example in this case. Suppose I have to multiply, say, 302 by 121. A simple example where there is no carryover involved. This dot represents 3, this dot represents 0, this dot represents 2, this dot represents 1, this dot represents 2, this dot represents 1. So the first step says multiply these two numbers. Here I have 2 times 1 is 2. The second step says cross multiply like this and like this. We will add both the answers. So 0 times 1 is 0 and 2 times 2 is 4. 4 plus 0 gives me 4. Step C says multiply like this and like this. So 3 times 1 is 3, I put 3 in my mind. 0 times 2 is 0, I put that in my mind. And 2 times 1 is 2. My answer is 3 plus 0 plus 2, that is 5. Step D says multiply these two numbers and these two numbers. So 3 times 2 is 6. 6 I put in my mind, and 1 times 0 is 0. So 6 plus 0 gives me 6. Last step says multiply these two numbers, left and left. 3 times 1 is 3. And you see our final answer that we got in only one line is 36542. If you would have used your normal method, first you would have multiplied 302 by 1, written down. In the next line you would have put 0 and then multiplied 302 by 2. In the third line you would have put 2 zeros and multiplied 302 by 1 and then added all the 3 answers to get the final answer. That would have taken you 4 lines to get the answer. But using the technique given in Vedic math, you can get the answer in only 1 line. This is the beauty of these techniques. Next, we will see how to use examples where there is a carryover involved. Suppose I have to multiply, say, 352 by 121. Let us see how we get the answer. First step says multiply these two numbers. 2 times 1 is 2. Second step says cross multiply like this and like this. So we have 5 times 1 is 5 plus 2 times 2 is 4. 5 plus 4 is 9. Third step says multiply this like this and like this. So it will be 3 times 1 is 3. 5 times 2 would give me 10. 2 ones are 2. So 3 plus 10, 13 plus 2, 15. I write 5, carry over 1. Step D says multiply like this and like this. So 3 times 2 is 6 plus 5 times 1 is 5. 6 plus 5 is 11 and 1 gives me 12. I write 2, carry over 1 again. Last step says multiply these two numbers. 3 times 1 is 3 and 1 carried over becomes 4. My final answer, you can see I got in only one line. It is 42592. Thus, with the help of Vedic maths, we can get the answers of complicated multiplication questions in just one line. Let us have a look at the last example in this case. Suppose I have to multiply, say, 912 by 801. First step says multiply these two numbers. So we have 2 times 1 is 2. Second step says like this and like this. So 1 times 1 is 1 plus 2 times 0 is 0. 1 plus 0 gives me 1. Step C says like this and like this. So 9 times 1 is 9. 0, 1 times 0 is 0. 16, 2 times 8 is 16. 9 plus 0 plus 16 gives me 25. I write 5, carry over 2. Step D says multiply this and this. So 9 times 0 is 0. 8 times 1 is 8. 8 plus 0 is 8 and 2 carried over gives me 10. I write 0 and carry over 1. My last step says multiply these two numbers. 9 times 8 is 72 and this 1 carried over will give me 73. My final answer, as you can see, is 730512, which you can see I got in only one line. Friends, ever since we started teaching Vedic math, we have got a tremendous response, especially from students who are giving competitive exams like GMAT, SAT, GRE, CAT and so on. Students often ask me how Vedic math techniques can be helpful in such competitive exams. Well, all the techniques can be applied somewhere or the other. I will give you one example of how you can apply this crisscross system when you are giving such competitive exams. Remember, in many of these exams, you have one question given to you and 4 alternatives. That means 4 answers are already given, out of which you have to take one answer as the correct answer. In such cases where you have 4 options already given to you, the systems of Vedic math can be of immense help. Let me give you an example. Suppose I am giving any such competitive exam and there is a question in my paper which says, say for example, I have to multiply 358 by 121. Now I know they don't ask such simple questions, but we are just taking one hypothetical situation. And against these questions, I have been given 4 options, out of which I have to select one as the correct answer. Let us say my 4 options are 43328, 43328, 3 3 9 8, 4 3 3 1 8, and D 4 3 3 1 6. Out of these 4 choices, I must take any one as the correct answer. So let us see how we can do it. I write my question here, 358 times 121, and I apply my Vedic math system. First step says multiply these two numbers, so I have 8 times 1 is 8. Now the moment I have 8 over here, I look for all the alternatives that end with 8. Here option A ends with an 8, so it is a possibility. I come to option B. Option B also ends with 8, it is a possibility. I come to option C, it ends with 8, so it is a possibility. And option D ends with a 6. Well, there is no 8 over here, but I know for sure that my final answer ends with an 8. But since I have a 6 over here, I know my answer is definitely ending in 8, but option D says that the answer is ending in 6. It's a different number. Here it is 8, here it is 6. I can conveniently presume that D is not my answer. It cannot be my correct answer. Let's move ahead. We still have 3 probable answers, out of which one is correct. Step B says multiply cross like this and like this. So I have 8 times 2 is 16, plus 5 times 1 is 5. 16 plus 5 is 21. I write 1, carry over 2. Let me look here. 18 is there in the end or not? Option A ends with 28, so it cannot be my answer. I need 18 in the end, so I cancel option A. Option B ends with 98. It cannot be my correct answer because I need 18 in the end. Option B is ruled out, and there is only one option left, option C. Here also 18, here also 18. I can conveniently tick C as my correct answer. My final answer is 43318, which I get without working out all the steps. You see, I have only done 2 steps. I have not even done the remaining steps. The moment I got a unique option matching with the answer, I straight away ticked it as the correct answer. So here I am saving so much of time, energy and labor. That is why in such competitive exams like GMAT, SAT, CAT, GRE and many other exams where time is very critical, you must get the correct answer very fast. These techniques of Vedic math can be of very much help. When you use the traditional system, you don't get the final answer in the first line. You have to go through all the intermediary steps till you get the final answer. So this advantage is not available in the traditional system. It is only in Vedic math that you get the final answer in one line, and that is why we insist that these techniques are very, very powerful. Friends, we have seen 2-digit multiplication, we have seen 3-digit multiplication. Like this we can go on and on. We can multiply 4-digit numbers, 5, 6, 7, 8, 9. Any digit number by any digit number, you will get the answer in only one line. In my book Vedic Mathematics Made Easy, supplied to you along with the course, you can see designs of higher order numbers. Here we will only take one example of 4 by 4 so that this concept becomes clear. Let us draw the design. For 4 by 4 multiplication, we use 7 steps: A, B, C, D, E, F, G. We have 4 dots above and 4 dots below. Let us see how to join them and form the design. So step A goes like this: 1, step B has 2, step C has 3, step D we take all 4, again here we take 3, 2 and 1. After this example is over, I will teach you a technique by which you can learn how to join these dots in a particular pattern. First, let us have a look at an example. Suppose I have to multiply, say, 2, 3, 1, 2 by 1, 0, 1, 0. Step A says multiply these two numbers. So 2 times 0 is 0, Step B says multiply like this and like this. We will add both the answers. 0 plus 2, 2. Step C says multiply this, this and this. So we have 0 plus 1 plus 0, that is 1. Step D says take like this, this, this and this. Join the extremes and join the middle numbers. So here we have 2, zeros are 0, 2 ones are 2, 0 plus 2 plus 3 plus 0. So it is 5. Come to step E, join this, this and this. So we have 2 plus 0 plus 1, that is 3. Step F says like this and like this. 3 ones are 3, 2 zeros are 0. 3 plus 0, 3. Last step says multiply these two numbers. 2 ones are 2. My final answer is 2, 3, 3, 5, 1, 2, 0, which you can see I got in only one line. Friends, whenever we learn a new technique, we think it's difficult, but no technique without practice can give you mastery. When you look at these dots and designs for the first time, you might get stunned or frightened, but worry not. They follow a scientific pattern or order which is very easy to find out. Next, I will teach you how you can form the steps that are used in this technique of multiplication with designs. Well, we follow a simple formula, the formula to get the number of steps, because unless you know how many steps are there, how can you join the dots? The formula is very simple. The formula says double minus 1. I repeat, double minus 1. Let me tell you how it works. When I multiply 2-digit numbers, now 2, double of 2 is 4 and 4 minus 1 is 3. That means I use 3 steps. When I multiply 3-digit numbers, double of 3 is 6 and 6 minus 1 is 5. So I use 5 steps, A, B, C, D, E. Similarly, when I multiply 4-digit numbers, double of 4 is 8 and 8 minus 1 is 7. So I use 7 steps. Suppose you have to multiply, say, a 10-digit number by a 10-digit number. Double of 10 is 20, 20 minus 1 is 19. So we'll be using 19 steps. This is just a theoretical case. We never multiply such long numbers. After finding out how many steps are required in the procedure, I will now teach you how you can join the dots and get the answer. Joining the dots is also very simple. Let us see how that works. When you multiply 2-digit numbers, begin from the right. So I begin from the right, I take 1, go to my left, 2, again close and go to 1. So the notation that is used here is 1, 2, 1. When I multiply 3-digit numbers, the notation will be begin from the right, 1, go to your left, 2, go further to your left, 3. We have reached the maximum because there are 3 digits. Close, 2, close once again, 1. So here you have 1, 2, 1. Here you have 1, 2, 3, 2, 1. Here also, let us see the notation. We begin from the extreme right. We take 1, go to the left, 2, go to the left, 3, go to the left, all 4, close. We have 3, 2 and 1. So here the notation is 1, 2, 1. Here the notation is 1, 2, 3, 2, 1. And here the notation is 1, 2, 3, 4, 3, 2, 1. Start from the right, keep on moving towards the left. After you have reached the maximum, you can close. For 2 by 2 it is 1, 2, 1. For 3 by 3 it is 1, 2, 3, 2, 1. 4 by 4, begin from the right, 1, 2, 3, 4, 3, 2, 1. Also you can see first and last steps are mirror images, second and second last are mirror images, and there is a central figure. Look here. A and C are mirror images of each other. If you put A in front of the mirror, it will become C, and B is a central step. Here A and E are mirror images of each other. B and D are mirror images of each other. If you put B in front of the mirror, it will look D. And C is a central figure, it has no mirror image. Here you can see A and G are mirror images of each other. They are opposite pairs. B and F, second and second last are mirror images. C and E, third and third last are mirror images. And D is a central figure. So these are the characteristics of the steps. Once you understand them, you can form steps on your own and multiply any number of any length and get the answer quickly. Now we will see two steps, one with unequal multiplication, and then I will teach you how this technique can be used in algebra. Friends, we have seen how to multiply 2-digit numbers, 3-digit numbers, 4-digit. But what if there are unequal digits? Suppose you have to multiply a 3-digit number by a 2-digit number. Then what do? Very simple. Suppose I have to multiply, say, 320 with 32. 3 digits on the top, 2 digits below. What I do is very simple. I put a 0 here and I make it 3 digit and my answer is done. Now I can use the technique of 3 by 3 and I can get the answer straight away. 0 times 2 is 0. It will become 4 plus 0. 4. Step C will be 6 plus 6, that is 12, plus 0, still 12. I write 2, carry over 1. Step D is 3 3s are 9 plus 0, 9, and 1, 10. So I write 0, carry over 1 again. Last step, 3 zeros are 0 and 1 carried over becomes 1. So my final answer is 1, 0, 2, 4, 0. Friends, we have seen how to use the criss-cross multiplication when we do arithmetic. But the same can be used for algebra also, where you can multiply algebraic expressions and get the answer very fast. Let us have a look at a simple example. Suppose I have to multiply, say, a plus b by a plus 3b. First step says multiply these two numbers. B into 3b would give me 3b square. Then put a plus sign because both are plus. Step B says cross multiply like this and like this. So here we have a into 3b, that is 3ab, and a into b is ab. 3ab plus 1ab gives me 4ab. Plus last step says multiply these two numbers. A into a is a square. Our final answer is a square plus 4ab plus 3b square. Friends, let us see an advanced example in this. We have to multiply 5m square plus 5m plus 5 with the same number 5m square plus 5m plus 5. So first step says multiply these two numbers. We have 5 5s are 25. Second step will be like this and like this. So we will have 25m plus 25m, that is 50m. Step C will be like this and like this. So it will be 25m square plus 25m square plus 25m square, that becomes 75m square. Step D will be like this and like this. 25m cube plus 25m cube, that is 50m cube. And the last step will be these two numbers. Multiply these two like this. 5m square plus 5m square is 25m4. My final answer is 25m4 plus 50m cube plus 75m square plus 50m plus 25.